al gebeurd. Kan ik dat zelf ook wel even doen. Het staat al aan. Heel goed. Welcome everyone. I should switch to English because we always do this in English. So welcome everyone with this new version of the Center for Sustainability Circular Industries talks. And today we have with us Barend Ubbink. Barend is a sustainability advisor at Into Waste, and he will telling us about some interesting innovations with regards to sustainability projects. I have had the pleasure to visit Into Waste, and it's if you ever have the chance, please do so, because I think it's very interesting to see what they're doing. And I'm really happy, Barend, that you're willing to talk to us today about the circular economy and the current challenges in e-waste. So the floor is yours, Barend.
Thank you, René. Welcome, everybody. First of all, also thank you, Rosanne, for making this opportunity possible. As René already mentioned, I will give a presentation on the circular economy and the current challenges in e-waste. I will focus a bit on the practical side because I already saw that Max van Beek and Doreen van Donner already did the part on a really nice presentations on recycling. So it's I will point out a bit from the supply chain how many of the e-waste is coming through complied recycling processes. So I work at Into Waste Solutions. That's a part of the AM recycling group. We are with 85 persons working here. The company is 21 years old. And I will talk at the end also a bit what we are doing for the circular economy and also the social economy. So, yes, so there's an increase of e-waste in a report that I read from the Global E-Waste Monitor 2024, which used data of 2022. There's an increase from 34 billion kilograms in 2010 till now in 2022 of 62 billion kilograms. So why is that? Well, I try to visualize it a bit that we are substituting to an electrical version from pen and paper to an iPad, some of us with or other electrical device to write, but also you see it in changing from cigarettes to vapes. And we already had a container full of vapes that needed to be dismantled because in everything there's a battery in it. So what more is conductivity also in the house, smart refrigerator and a smart oven that you can put on if you're on the road home. Also energy saving equipment. So on one side, it is a good thing because you will use less energy, but on the other side, we need raw materials for that. And also problem is the limited repair options. When it's broken, most of the times it cannot be repaired, so it will be e-waste. So further in the supply chain of the new raw materials or secondary raw materials, I think everybody can notice for themselves as well that somewhere in a drawer at home there are some hard disk or phones or some other electrical devices. This picture downstairs is at my place, and I found these hard disk and mobile phones within 5 minutes in my house, and I think I got more of that. So I'm also guilty of having a lot of precious metals at my home. That is better to go into a recycling way than staying in a drawer. So if you look at documented e-waste that is collected and recycled in a proper way in 2022, there's globally 22.3% And Doreen had numbers, I think, of 2019, where it was 17.4 or something. So there's an increase in it, looking globally. Also in the Netherlands and in Europe, there is an increase in the e-waste that is going through a compliant way. And why are these numbers so low? I think on one hand, perhaps it is now we are changing a bit to an on-demand way of living. So I had here a school, and a person asked me, "Well, I see all these e-waste or all these tablets. I got also these things at home, but where do I? How do I know where I need to bring it?" And that was the same time that there were in the Netherlands commercials of bringing your e-waste to or a supermarket or to the municipality or but if we look at all these on-demand streams where there's no commercial, then this kind of information is not getting to the persons. So that's perhaps one of the reasons why there's a lack of e-waste that is going to a documented way. It's ended in a bin, just like from the wish cards with music out of it. That is e-waste, but probably it will be thrown away in a recycle bin, or perhaps in the paper bin. So another challenge is also the product diversity. It's really, if you want to sort all these products, there are different sizes, different colors, different types, also for dismantling. So that makes it also rather difficult or more intensive to sort the right materials together, and also to recycle it. And also, I think for reuse, because if there's no standardization, it is difficult to use components from different brands in other products. So it's also labor intensive. Most of the electrical products, they are very compact now. So they are screwed or glued together in a very tight area. So it takes really a lot of time to dismantle such electrical products, and if you want to reuse it, you also need to do it in a clean area, and also in a very proper way. So that makes it labor intensive. And with that, looking at in Europe or in the Netherlands, labor intensity means that there are more costs with it because labor is taxed higher in the Netherlands than new products. So that makes it sometimes cheaper to buy something new instead of buying a refurbished or a product that is being repaired. So then there's also the challenge of reuse versus destruction. Here I want to show like a metaphor is on the hard disk. There are still perhaps data on it. You can wipe it, but if something is shred, then that makes it visible that data is being destroyed. And here again, in the reuse, you need to dismantle it if you want to go on the components, and that again is labor intensive. So the price you need to pay for this investment, it can be higher than new. There is a reuse mark on IT components. It is that is already going on. It is on servers, and there are some companies in the Netherlands that's working on that. So there's a potential. We also look into it. We have now a student that is doing a thesis on this part, and I think with the what is going on with right to repair, but I will tackle that later on. I think this market will grow more. So another challenge are the batteries. I already mentioned it before, but batteries needs to be dismantled manually. Sometimes they are not at a convenient place, or it's really difficult to dismantle it. But the batteries brings also fire hazard with them. Batteries are thrown in the garbage bin, and then if you look at the right, it is the garbage truck is caught in fire because of these batteries in it. Overcharged devices, like the picture below, can be also dangerous at the recycling facility, because if it's caught on fire, you will have a fire at the plant. And also missed batteries that are still perhaps in products that is going to shredder brings some dangerous situations at recycling plants, and batteries that ended up in a recycling pill. So perhaps you got an e-bike, but the battery is in the frame or something, and that battery is going to the pile of steel or something, and then after it's piled up, something breaks the battery and it got fire. So that's, you see at recycling plants also more fires now, and that's mainly because of the batteries that are used in everything, or almost everything nowadays. So what are the developments now from regulations? So one I mentioned is a right to repair. I think that's a really good one, because then the lifetime of products will grow longer. We can use them more. And I also think here there's the society is also a bit changing, because if we don't want always the new products, we can use products longer, and if we can repair them, if the battery has a low state of health, and you can put a new battery on it, and furthermore it still works, that will result, I think, in less e-waste. And also the Critical Raw Material Act will probably do something on the recycling rate of some critical raw materials. Like Europe said, we need to extract 10% of the materials here in Europe. Also 40% processing it in Europe, and the recycling should be 15%. So there will be a change I think in also in the recycling, and you see, looking at pattern, that's also mentioned in the global e-waste report of 2024, that there's really an increase in patents asked about recycling. Yeah, and if you look at these critical raw materials, I see a misspell. There's a lot of elements in it that are not or low recovered. So one, and I think René also mentioned it in an earlier talk, that's neodymium in the magnets. Well, there's a lot of, so there's almost 7 million kilograms of that in e-waste now in the world. So if we can retrieve that, and if we and use it as a new or a secondary raw material, that will help us within building new magnets, and also with the energy transition. So looking, putting effort in how to recycle, how to win it again. It's a really good, I think it's a really good thing, and will help us in the future also to be independent. So what's also a current challenge is that we build things and that's also the part of Doreen. So we build things, but we don't take a bit design for recycling with it. So there is a sustainable waste pile perhaps coming up with all the first generation solar panels and windmills that are being end of life, but we don't know yet how to recycle them. So I found this is nearby my place, and it's a kindergarten place where there's they build it from old windmills. So I really like it, but if we all will do that in such a way, there will be a lot of these playgrounds. But that's not the answer. This is nice for visualization from what the problem is, but it would be good to put in effort and also to take into account for new products, how can we recycle it? And yes, there's also there's I think always design for safety, and afterwards comes design for recycling. But if we look more to that, it will be also perhaps the e-waste will grow, but the recycling rate will also grow if everything goes into the right documented recycling scheme. So now that brings us, what do we do at Interwaste and A&M Recycling? So first we are a host for schools, and we are at Jeugdland, that's always in the holidays in Rotterdam, in Ahoy. And there we get children, and we give them the first learnings about recycling. What is recycling? Why do we do it? And then they always can dismantle computers, and they really like that. So on the other hand, the youth is getting knowledge about recycling and why it's important. But on the other hand, if they're coming home and their parents ask, what did you do today? And they will tell the story about recycling, then that is the recycling is also going from down up to everybody. The other thing is that we are doing with Saxion Hogeschool research on machine learning for PCB sorting, to make them, they will sort them in different bins, depending on what the quality and the quantity is. And this should make the work easier for us, but as well, this should make it also a bit quicker, so we can, we are not dependent on manual labor, but the machine can go on, so we can sort more PCBs than we do now. We're also part of the Circular Circuit project, like the presentation of Max and Doreen. And we found these kind of projects important also because then we know what is happening, but also we can see what are the innovations in it, and can we help with that. We also started a new company that is really dedicated on reuse. We already did that, but it was part of daily business. But now it's fully focused on reuse of components, and that is not only e-waste, but more on structure, steel, and these kind of things. As I mentioned already, research on reuse legacy components. She's almost finished, but that's a pity that I cannot share the results with you. But that will be perhaps later on. And one of the things as well is that we are founding partners of the Circular Campus here in Rotterdam. That's a doorbraak project from Team Next. Team Next is we are members from that as well. That's in Regio Rotterdam. That's from entrepreneurs that is really want to change education, but also sustainability. And with the Circular Campus, we have students from Rotterdam Hogeschool. Together with the company, you will have a course for 1 month with college of lectures of Professor Jan Roopmans of the Erasmus University, but also Yuri van Geest, and they tackle a bit the technical part, technical innovations, also nature principles, and also circular economy, and the raw material transitions. So that's yeah, I think it's a really nice project, and the Circular Campus wants to start in September. We did a pilot, and I was part of that, and it learned me a lot. It brought me a lot. So I hope this will be a success. So that was my presentation on the challenges. Thank you for your attention. And which questions do you have for me?
Thank you, Barend. I'll give you a real hand, and there might be some virtual hands as well. Thanks for your presentation. I think it was a really nice overview of these challenges that are currently well existing, let's say, in this recycling of especially electronics, etc. If there are any questions, just raise your hand or raise your virtual hand or open your mic if you like. Maybe I can kick it off with a question for you, Barend. If you look at these printed circuit boards, there's like you said, you wanted to use machine learning to make selections of, and I know that in these circuit boards there's a huge difference. In some will contain a lot of valuable materials, and some will contain very little. So on how do you actually do this? How do you recognize those circuit boards that actually contain a lot of valuable materials and which don't?
So yeah, that's a really good question. Thank you. Well, this is part of the knowledge that we got. So we learn it by giving the system values that how we our operators choose it is an A or it's a B or it's a C, and that's really on content of components on it. As well of connections and this solder or weldings. So there are some criteria that they choose for it, and then we learn the computer, and hopefully it will go. We are now in the learning phase. So when we will start testing it. Yeah, hopefully it will do as what humans do as well, because that's the challenging part, indeed. Because also of the colors on it, black, sometimes difficult to recognize what kind of component is it. Is it value or not? So it is rather, the project is also taking, it's a long project now, but hopefully we will succeed in it. But it's different,
Yeah, I think
difficult, yeah.
Yeah. I see a hand raised by Peter.
Yes, good morning.
Good morning, Peter.
Oh, something. Yeah, better like this. Hey, thank you for your overview. You mentioned the risk of batteries in waste with fires. There are several ideas to detect batteries. Do you follow them? Do you see any promising technologies? There's, for example, a small Norwegian company claiming that they can detect them sometime, but it's very, very vague. What's your impression on this subject?
Thank you for your question, Peter. Yeah, it's I follow it. Yes, and some ideas. I think that's also there's a student team in the Netherlands that wanted to use AI for it. The Norwegian part, I didn't know that, so thank you. I will look into it. I think that's by recognizing first, because we can standardize it, and I think with right to repair the batteries, because a battery is one of the components that needs to be repaired, I think, more often because of the state of health. So with that, that will make the batteries in a sort of a standardized place, but that is for new products that are coming. So for the old products, it would be really handy to have such a system that can detect the batteries. We all know a bit how radiation is detected, but that's with these poles at the entry of a yard. So that will be very helpful.
And how will they be detected, Peter? What is the what is how does it work? Do you know that?
No, the Norwegian company claims with magnetics.
Oh, okay.
Okay.
I
So
think
yeah,
high
so
frequency magnetic fields, but I'm not aware of the exact physics, what they detect, and penetration depth, things like that. And it's so vague that I'm not convinced that it's actually working.
Yeah.
So that's why I'm, and because there's a lot of money damage involved, millions,
Yeah.
if not more. I'm interested. What's the opinion of A&M on this subject?
Yeah. So yeah,
If you
there's
see any.
well, that's one of the reasons why we do some batteries, but more lead acid battery collection, because also of the danger of these lithium-ion batteries. So we're really a bit thrilled of it, and now there are some developments also on safety. But indeed, all these small batteries, and I think that's the danger of it. We really look at all these devices. If it's potentially got a battery, we will put it separately, and then it will be dismantled at facilities of us that we have with the social rate of return, so social employments, and they will then dismantle these battery. Perhaps products with batteries. So we take them apart. If we think perhaps there's a battery in it, and we cannot take it out, it will be put in a special bin.
Yeah. But that all depends on knowledge of the content and the construction of the products.
Yeah. So that's really depends on the knowledge, and that's now done by persons, and they really have this knowledge. So that's also changing that to automatic or machinery takes a lot of learning, I would say. And now that you can see, okay, perhaps there's a battery in it. I will put it here, and there's a battery in, and then they dismantle it and it go further. So that's a really challenge. So and I'm really I will look into or if you got some information about the company in Norway.
I shared I shared the link in the chat.
Great, thank you.
Yeah.
I was also wondering, Barend, so connected to this, so there's a lot of talk about digital product passports nowadays. Would it help you?
Yeah, well, that's the Circular Campus project. There are 4 companies doing it, and we are one of the founding partners in it. So we also have their students, and they are working on material passport. It will really help. It will help in several ways. Also, the circular economy by knowing what is in it and how can we exchange it or repair it. And for us, it's also helping us because if pure looking at steel, there are so much different alloys, and knowing which alloy is where or something will make perhaps also the dismantling easier. And you can sort it with technology. Yeah, that's true. With sorting techniques. That will help dismantling, and that will also help sorting. Definitely.
How would it help in practice? Because you get a lot of, let's say, stuff in, and then you have all these different digital product passports. So how would that work in practice? So would your employees then be looking at these PDFs and looking at these?
That's a question I cannot answer now because we need to know that. And yes, then they will have all a tablet or something, and then need to scan it. Okay. So in practice, that still be some challenges. So perhaps on the forehand is really for right to repair. it will help, and also for dismantling, looking at buildings and these kind of things. But on the yard, perhaps they will say, that it costs too much time or something. Yeah, so that we need to find out. Now that's a lot of knowledge. Look at where it's from. Okay, so it was used for like say storage assets or something. Then okay, if it stores assets, then it cannot be this or it cannot be that kind of steel. So that's the knowledge they have now. So perhaps you should then only use it on products where you're not certain of it. So that will make it. That's a good question.
I could also imagine, and I could also imagine that, for example, I mean, you want to have this automized somehow, because you don't want to have people looking at PDFs and information like that. I think that doesn't work. So probably what you would, in the ideal situation, we just have a conveyor belt with stuff on it, and then there's a picture made, and then based on the picture, the machine knows the digital product password and knows whether it goes into bin A or bin B or bin C.
So perhaps it will go in that way, and then really depending, and then we focus on e-waste then, and then you can focus on the small e-waste because we also got really large industrial structures that need to be dismantled that you cannot put on a conveyor belt, or you need a really big one. But for these kind of things, probably it will help, and you see it more often now already with sorting machines of household waste, like they're already getting out the kind of plastics. So at the end that will also be possible with, or perhaps some companies already use it. These kind of ways for e-waste.
Thanks, Peter. You raised your hand again.
Yeah, I'd like to comment on that. In Switzerland, there's a national system of e-waste processing, and that national organization is already using this what René described. They use it to optimize their installations because they scan what's on the conveyor belt and have estimates for what's in it on materials, and they can use it to adjust their machines. They also use it to find usual products with value in it automatically, because this organization is not paid by the producers but under the government. They also try to bring that to the second-hand circuit. What a producer paid organization does not like, because it competes with new products.
I think that's also a challenge. But thank you for this information. But that's also a challenge. And I didn't tackle it in the presentation this time. But companies want to sell new things. So the right to repair isn't that great. Perhaps they need to change their system, and everybody talking about lease products or something that the company stays owner, and then they will build products that will produce product that will last longer. But companies that want to sell products, that is also a bit withholding the circular economy, because of all the labor costs. If you look in the Netherlands, and if you buy something new is cheaper, then you need really to have a sustainable focus on saying, okay, I will pay this time more for to repair it. And yes, these people are there, but I think the majority will perhaps choose for the cheap new one.
Yeah, interesting dilemma. Taco, you raised your hand. Oh, you froze up. So I can't hear you at the moment. Maybe we'll go to Tim first. Tim.
Yes, hello. Good morning. Thanks for your presentation. You mentioned already some specific challenges, right? So I'm wondering, where do you see the biggest bottleneck when it comes to the aim to increase the recycling codes? So is it on the collection side? Is it the recycling technology? Or is it, for example, the missing business case? So maybe in short, like, where should we prioritize right now in the short term?
Yeah, thank you for your question, Tim. That's a really nice one. And if we look, I didn't tackle the whole financial part, but in the report I mentioned there is they state the business case. There are a lot of I got a slide on it if you look at the revenue in my backup, but there are a lot of revenues, but the cost of these compliance systems makes it not profitable. That you should put money in. But if looking at your question, if the e-waste is going the rate from 22% globally to more, or in the Netherlands then 60% to more, then you got more materials, so then you can invest in more recycling facilities, or going more into detail on that. So getting more e-waste in the proper way will help, I think, also in a higher recovery rate. And on the other hand, with all this legislation that we are doing now in Europe, like the Critical Raw Material Act, and if that will stay like it is, or then you will look at the battery directive. There, recycled content need to be put in new batteries. So you're making a business case for recyclers, because they know they will produce products that are secondary raw materials that will be used in new products. And now sometimes people say, no, I want virgin because then I know the quality. So that's, yeah, there should be a shift on using more secondary raw materials. And I think in metals, it is already, they use a lot of secondary materials, but I think that will help making the value. So valuing secondary raw materials instead of, no, that is waste and that is recycled, I want to pay less for it. So that will help the business case.
Yeah, I think also this is where the government should step in with measures on, let's say, recycled content, because in that way you can create the business case, even if it's not there, let's say, for automatically. I think that's a crucial point there. That I think that's a role that government should play in this. Respect.
In this case, sometimes it's the entrepreneurs that is doing the change, but now indeed, if the government say this, you need to do that, then it will help.
Yeah, you can already see that in many sectors, right? For example, in the automotive sector, where you have recycled content legislation in place, there you can see that there is a whole market for recycled plastics, simply because they require to have a certain amount of recycled plastics in their products, and that helps a lot for the recyclers.
Yeah, and in the car industry, there you also see it, all these dismantling plants, a lot of parts that are being resold.
Yeah, exactly. Yeah, those are mostly valuable parts. There's also a whole market and an industry for that. Yeah. Taco, I want to come back to you. You froze up last time, but I hope it will be okay now.
Yeah, I seem to have a bad connection this morning. But thanks again, both you, René, and Mr. Ubbink. I work for the Dutch government. I work at the Ministry of Foreign Affairs. And so, one of my questions was already answered. The other question is, you are familiar with the critical raw material strategy of the Dutch government, I'm sure. What would be important for into waste under that strategy? That's one of the questions. And one of the second question is when I talk to recycling companies, one of the main problems is to have a constant stream of waste getting to their companies. Is this also the case in the case of into waste, or did you find solutions for that? Thanks.
Yeah, thank you, Taco, for your questions. Yeah, what is the question first? Well, we had the critical raw material team in Circular Economy of AZK. They visited us, so we had a conversation on this. At one part that is permits. We talked about that because if you want to start, you see it. I think a lot of the circular economy or recycling and takes. You need areas and sometimes it's not in my backyard systems, but getting a permit can take a really long time if you want to change your if you want to grow. We need more space, then you need more a permit because you're growing, so that takes a lot of place or a lot of time. So that is something what we need from the government, I would say. Also, when products are coming into a recycling yard, they will get the stamp waste, and getting it off waste. And yes, there's a lot of talking about this, but the waste laws in the Netherlands, they were established in the time that we really had problems with waste and with fluids and pollutions. But now sometimes I think it is getting the circular economy or the recycling bit. It stops a bit because of all these rules and getting the end of waste certification. So if you look, yeah, and I think if in the Netherlands, if we want to stay independent as well, and being a country that has his industry, I would say more places of innovation for these kind of recycling plants or refining metals. That would be to stimulate that, and I think that stimulation also needs to be done with education. So there, I studied mining engineering and petroleum engineering at TU Delft, and there you see really now is change going on, and I think as the Netherlands, we really should, to be a bit focused on that. We're not losing all this knowledge. By saying, mining, when I say I did the education, mining is what are we mining then? And mining is polluting. And on the other end, we all want to have a mobile phone and a laptop and these kind of things. And there you need raw materials for. So you need to mine or to recycle it. And your second question, so the continuity of waste streams. There we do projects also on infrastructure. There you saw with the nitrogen problem that these projects were put on hold. So there you really saw a decline. But on the we are mainly focused on metals. So I think the continuity problems are more with the continuity of the same plastics than in the metals. But I know from plastic recyclers that yes, the continuity there. If you want to sell it or to have a contract with producers, you need to bring a constant grow of quality, and that's sometimes in plastic recycling an issue, yeah. But that's also because there are a lot of sort of plastics with all these additives. So perhaps there the chemical recycling of it will bring an outcome, bringing it back to a base, and then you can build new plastics of it or produce new plastics of it. I hope this answered your question.
Thank you both. Maybe for one final question, we go to Zhao Wao. I'm not sure whether I'm pronouncing your name correctly, but
thanks. My name is Zhao Tan. I'm professor of ICT at the department TPM of TU Delft, and looking a lot with Boriana Rukanova together in all kinds of. So we have various EU projects on critical related to critical raw materials. And one, so we are just about to start a new National Growth Fund project, Groeien met groen staal.
Yeah.
And so are you aware of this initiative?
Yeah, I've been to a meeting last month in Utrecht, and that was the first time I heard about it, and that's really interesting. So I need to follow up it so that we can contribute with that.
Yeah, okay, so that would be helpful. One other question. So we have a lot of collaboration with the European Commission, and in particular Germany and France when it comes to automotive. So there are many pilots by BMW, Renault, and the likes. And it turns out that so it confirms exactly what you described, that there's already a lot going on in reuse of recycled metals in the automotive. That actually somebody explained to me that it's even part and parcel of the field. So that metallurgy, so basically it has been already for ages that they use 30% recycled steel that gives better quality steel. So in that sense, there's already an existing business model available. But also our impression is that in particular, so we were very close with Renault, we still are, so that they do all kinds of pilots with plastics, and that actually I forgot the name of the company, but there's a big recycler company in France, and they were able to, because then the question was, of course, okay, with plastic you get in a lot of an enormous variety of quality of plastic, so you really have to, before you can process that as recycled content, you really have to do a kind of selection process, chemical selection process. But it turns out that those big recyclers already have that in place. So they really can differentiate when they get load of recycled plastics from Renault, then they do filtering themselves. And it turns out that basically they were talking about percentages of 70-80% that they can recycle. So I was wondering, because you mentioned that that's lacking behind. Well, I can imagine in the Netherlands, but I would, so for instance, in Germany, well, in particular in France, we know of. With Germany, with BMW, we know less. But how do you see that?
Thank you for your question. Well, I worked before Into Waste at ARN, so Auto Recycling Netherlands. So
we know them. We know them well. Yeah.
So and in the time they had the post shredder technology plant in Tiel. It's still running, but not anymore within ARN. So indeed, I think the company you mentioned is also a bit part in Belgium. There because it is auto shredder residue, they use the plastic out of autos. Then you know what's inside of it. I know one of the problems at that time was the fire retardants in the plastics, mainly on the seats. So that was at that time a problem, but indeed the rest of the plastics, when you sort them into PP, PE, and ABS, and that was rather you could do that rather easily. Still you need to the whole process in Tiel was already very complex. And I think the more problem there was with the heavy plastics.
Yeah, clear.
But yeah, in the automotive, it's and Renault and other companies. And I think Renault was one of the first with the Espace. I think a lot of recycled content. And then the one problem that was encountered was the changing of the reach, because cars mainly, if you look in the Netherlands, 20 years old average. So when a car is recycled, and you see it now with other elements like chromium 6 or with PFAS, and that I think was the problem with the fire retardants, that wasn't allowed anymore. So then it's really difficult to recycle that kind of plastic, because it takes a really long lifetime. And in that time, we know more and more about the chemical process. But with the plastic without these additives, that's really they use it.
Actually, ARN is one of the partners also in this new the Groeien met groen staal. So what we can keep you connected. So my colleague is more actively involved, Boriana Rukanova, but I will send her details. And the other thing is that I now remember the name of the company. It's called Gallo. It's in the north of France.
That's the company I mentioned. And
they
are also a bit in Belgium.
Yeah, exactly. But it was very interesting. We had some interactions with them. And it turns out that they consider it as strategic knowledge that they have. So the skills they have in pre-selecting granulated plastics, so they were not very open to share any insights there. So to that extent, I can imagine that it's a kind of unique thing that's happening in France right now. But anyway, ARN has close contacts with Gallo. So do you know Jeannette Kess?
She was my colleague in it.
That's exactly. So she's our key contact person. Okay, but anyway, very interesting to keep you in the loop on this. And
great.
So unfortunately, I could not attend because I had another meeting. I could not attend your presentation. But if you could send me your slides, that would be most helpful.
And it will be also. It is recorded, I think. As well.
All these talks are recorded and put on YouTube. So
I will watch them.
Great.
Yeah,
thank you.
And we from the Leiden side are also involved in the Groeien met groen staal project. So so it's a nice connection to be made, I think. So that would be excellent. So with that, I think also looking at the time, we have to wrap this up. Thank you again, Barend, for sharing your insights with us. And thanks to all participants for their active contributions. And hope to see you all during the next talk.
Thank you. Thank you very much. And thank you for all the questions. Have a nice day.
Okay.
Thank you all.
Bye-bye.